Yeah. Hello. Today we want to look at the part of applications. Application of differentiation to kinematics. We want to apply to motion. How we can apply differential calculus to motion. Yeah, this is basic summary of derivative of like 5 functions here. Constants have a derivative of 0, x to the power n, derivative of n, x to the power n minus 1, sine x is cos x, derivative of cos x is minus sine x, that of tan x is sec square x, and derivative of exponential x is exponential x. Like I said, we are looking at kinematics, or looking at the application of differentiation to kinematics. We want to differentiate I want to see how we can apply differentiation to solve problems that involve displacement of a moving body, velocity of a moving body, and acceleration of. That is, we are looking at how we can apply differentiation to displacement, velocity, and acceleration of the motion of a body. These are the physics in mathematics. So it's going to be a walkover for science students specifically. That doesn't mean that commercial art students will not get this as well. Now, looking at a problem here, where a particle moves in a straight line. A particle moves in a straight line. I hope you are writing. A particle moves in a straight line through O. O now is serving as the origin. So that at t seconds, its distance s meters from O is given by s equals to t raised to the power 3 minus 15t squared plus 63t minus 49. Calculate the distance when the particle is momentarily at rest. Calculate the distance when the particle is momentarily at rest. I give the question again. A particle moves in a straight line through point O, so that at t seconds, a distance s meters, s represents the distance, okay? Distance s meters from point O is given by this equation. Alright? Calculate the distance when the particle is momentarily at rest. Right? Let me quickly tell you that when we have a displacement equation, if s represents displacement or distance, okay, is what we have. Now you should know that the velocity is going to be ds dt, and acceleration is d square s dt square, or dv dt. Alright, so that is what you need to know. When we differentiate displacement, we have velocity. We differentiate velocity, we have acceleration. Or when we differentiate displacement twice, we're going to have acceleration. These are important formulas in kinematics. Now, let's solve this problem that we have. We have to find the displacement, we have to calculate the distance when the particle is momentarily at rest. First, since s is given to us as since our s is t raised to the power 3 minus 15t plus 63t minus 49, we have to find the velocity equation. Velocity equation, which is ds, velocity here is ds dt, and that is, when we differentiate tq, we're going to have 3t squared, and then we have minus 15t squared, please. This is t squared. So in differentiate, this is going to become minus 30t And when we differentiate 63t, we're going to have 63. While differentiation of minus 49 is going to be 0, because that is a constant. So we have 3t squared minus 30t plus 63 as our velocity equation. Then they say when the body is momentarily at rest, when the body is at rest, there is no velocity. That means the velocity must be equal to 0. So that means v is equal to 0, and that is still what 3t squared minus 30t plus 63. Now this leads us somewhere. We now understand that this whole equation becomes what? Becomes 0. So that's a quadratic equation. We can make it simpler by dividing through by 3. 3 cancels here, that's 3t squared. This minus 10t, and this is when we divide this one through, we have what? Plus 21 equals to 0. So solving quadratically, this is a quadratic equation. We're going to have that's t here, and this 21, this is 10. So minus 7 minus 3 equals to 0. So this is what we have. So we have t equals to 7 or t equals to what? 3. So when the body is momentarily at rest, that from this equation we have that the body is momentarily at rest either at 7 seconds or at the 3rd second. So all we have to do is what? Take this back into the displacement equation. Displacement equation is also the distance equation. So put 7 into this equation, we're going to get a value for s. Put 3 into this equation, we're going to get another value for s. So that means we have 2 values for the distance when the body is what? Momentarily at rest. So let's try that. Let's try that and get our s, because we're actually looking for s. So at 7, at t equal to 7, s is going to be what? 7 raised to power 3 minus 15 times 7 squared plus 63 times 7 minus 49. If we solve that properly, we are going to have what are we going to have there? We're going to have at 27, that's 7 cubed minus 49, and that's going to be 784 minus 784, and that's going to be 0. So that's going to be 0 meter. Okay, now at t equals to 3, at t equal to 3, we're going to have s equal to 3 raised to power 3 minus 15 times what's our t now? That's 3 squared plus 63 times 3, then minus 49. Okay, you know we are substituting for t in the whole equation. Then what are we going to have there? We are going to have 32 meters. So the answer at this point is what? 32 meters. So when the body is momentarily at rest, using the equation given to us, we have that s is equal to 0 meter or s is equal to 32 meter. So that is the basic art of application of differentiation to kinematics. Just understand that when we differentiate a displacement or distance equation, we're going to have velocity. When we differentiate velocity equation, we're going to have acceleration, and you can differentiate displacement equation twice to the second order. That is, we have s now as our displacement, then the square s, the t square is going to be equal to acceleration, or you say the v, the t is also equal to what? Acceleration. Remember, the s, the t is equal to what? Velocity. So that's what we just need to apply to get the right answer. Please, I expect you to go over this video once again. Go over it again and again until you have a clear understanding of what the idea is all about. And if you have any question, please, you can go to my blog and drop your inquiry or your question to my email. My blogspot is examsol.blogspot.com. Free ebooks and free video tutorials on various topics in physics and mathematics for all exam candidates. I congratulate you for going extra mile, and I wish you all the best.